Now we're going to talk about the project description, where the IoT motion detection system is designed to detect and monitor the movement in a specified area using NODEM MCU microcontroller. Then we're going to talk about the intelligence of the robotic system, where it illustrates the convergence of IoT and robotic because it can control using mobile phone. Then the project is controlled by NODEM MCU microcontroller, which improves the connectivity, monitoring, and control capabilities. The NODEM MCU microcontroller is a very flexible and powerful platform that can easily interact with IoT ecosystem. Then the current project uses NODEM MCU microcontroller to power an advanced line following robot in an effort to demonstrate the possibilities of this integration via this project. And our last project description is the project leverages the capabilities of the NODEM MCU and ESP8266, which is the motor driver, based development board with built-in Wi-Fi to enable wireless communication and to control it via using mobile phone. And right now we're going to talk about the layout design, where the first picture illustrates the top design of the project, and the second layout design illustrates the front view of the system, and the third layout design illustrates the back view of our project where the servo monitor will be placed, and finally the side view of our project where we'll be using two main tires and 180 degrees tire to monitor to control the movement, which will be easy for it.
So for the block diagram, we have the Node MCU microcontroller Arduino Uno at ESP32, which will be connected with Blink smartphone and also servo motor for the direction the motor. Then we have drive motor LM98 that will be connected to power supply, which is a rechargeable battery. And then we have two motor because we have two tire that will be moving as the main movement, the left DC motor and the right DC motor. Also on the ESP32 will be connected for the LED, which that will shows the motor speed. LED 1 for green, LED 2 for yellow, and LED 3 for red, and also be connected with power supply.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Amirul Sufi Hamis and I will explain about the system flowchart. So the first one is start. After the start, the process is RC card is turned on. And then the input execute is get token from the account and execute the device is connected. If no, it's come back to the input of get token from the account. After that, if yes, the movement input from link will get will receive and the output is send data to Arduino Uno. And for the last one, if movement at the DC motor and the end of the system.
Okay, good day. Today I'll be presenting about the schematic diagram. The circuit of the IoT car is based on the ESP32, where you can see that there's an input of 12 volt and regulate to 5 volt to give an input voltage of 5 volt to the ESP32 and connected to the motor driver of 12 volt. This motor driver provide two output for two each motor drive for the tire to operate, and therefore from the ESP we can see there's an input, 4 input from the ESP, two 4 output to the from the ESP to the input of motor driver to provide a signal that will give effect to the power operation to the motor. This is the system programming. As we can see, the program we have to define the blink template and the blink print of serial just to provide print out to the LCD. So the first three here is the three ID template from the Blink link that it will provide after the configuration of the layout and the system. And then we will include Wi-Fi client, and Blink Simple for ESP32, the file. Then for character authentication and SID and password, that is for the password. For the Wi-Fi, we consider for Hio Shaba with a password of 1 until 8. For the integer, we provide port number 4, 5, 12, and 13 from integer 1 until 4. And we provide code to move forward for integer 2 and 4, move backward for integer 1 and 3. The third one, for turning left, provide a signal to the motor drive from integer 2 and 3. And for turning right, signal from integer 1 and 4. Here we can see the pin mode where output for integer 1, 2, and 3. This we consider the pin that we use for integer 1 until 4. And the Blink authentication authentication, Wi-Fi ID and password, and we void loop, and then we run Blink.
For picture of project, the first picture shown is the top view of our project, which we can see the non-MCU and the motor driver. From front view of our project, we use push button to power up the project and 360 wheel for the movement left and right of our project. From side view of our project, we can see Li-ion rechargeable battery as our supply of our project.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about the discussion. So the first one is connectivity and communication. One of the central achievement of this project is the establishment of reliability communication between the ESP microcontroller and the Blink apps. Discussing the protocols used, such as MQTT or WebSocket, and shed light on the efficiency and responsiveness of the remote control system. Second one is a user interface design. The Blink app role in providing a user-friendly interface for controlling the car is crucial. Discussing the customization option available in Blink and how they contribute to a seamless user experience adds depth to the project's design consideration. Third one is hardware integration. Integrating the ESP microcontroller with the car hardware involve considerations like motor control, power supply, and sensor integration. Discussing the challenge faced and the solution implemented in the hardware design contributes to a comprehensive understanding of the projects. The fourth one is IoT in DIY projects. This project serves as a physical example of incorporating IoT principles into a do-it-yourself (DIY), discussing how the IoT concepts such as cloud connectivity and remote control can be implemented in simple projects provide insight into the democratization of IoT technology. The fifth one is future extension and enhancement. Discuss the potential of expanding the project, such as incorporating additional sensor of obstacle detection, integrating a camera for live streaming, or implementing automation features. This opens up a venue of future development and innovation within the project framework. 6. Challenge and solution. Addressing challenge encountered during the development, such as connectivity issues. Latency or hardware limitation provide a realistic perspective of the complexities of IoT projects. Discussing the solution implemented offer valuable insight for other undertaking similar project. Thank you so much.
For question part, first question is, in your opinion, where this project can be applied and what are the benefits to human being? The answer that we get is our project can be valuable if applied in application of home automation and security. By integrating the MCU with IoT-based movement control, we are able to develop a system that allows users to remotely control and monitor various aspects of their home. There are three parts we can get from a project that can be applied, which is firstly is convenience, which is users can remotely control the movement of device, and second one, the security. The project can contribute to home security by allowing users to reposition surveillance camera or other sensor in real time. Lastly, for energy efficiency, that we can implement smart control for light and other electronic device. For second question, which is from this project, give 2 example of other project that can be applied from this project and explain how it works. The first project we get is smart pet feeder, which we can create an automated pet feeder that can be controlled remotely through an IoT platform like Blink. And how it works is to connect a servo motor or a stepper motor to the MCU to control the opening or closing of the feeder. And we can use a weight or infrared IR sensor to measure the remaining food, and with Blink, users can schedule feeding time, check food level, and even dispense food manually from their mobile device. Second project we can apply, which is an IoT control surveillance camera, which we can develop a surveillance system with an MCU and a camera module that can be remotely controlled and monitored through an IT platform. And how it works is to attach a camera module to the MCU for capturing image or streaming video. Implement motorized control for camera movement, and with Blink can be used to create a mobile app that allows users to view the camera feed in real time, capture snapshot, and control the camera pan and tilt remotely. This is block diagram of our first project that we said before, which is smart feeder. And how it works is the power supply get to supply the MCU and separated by 2 part, which is relay for the water pump to output to for water bowl of a pet, and next relay for control the DC motor to implement a food to food bowl of a pet. For flow chart of smart pet feeder, how it works is firstly read setting time, and if it reach same as setting time, so when it successful, we can go to the next process, which is servo motor on, and if no servo motor need to be off and repeat to read the setting time. Next, after we get reach the same as setting time, the servo motor is on, and next delay for a few seconds. After that, servo motor off, and show read food level by using sensor, and calculate the percentage of food or water left, and it shows the display the percentage of food and water left, and that is how it works. For next project, which is IoT control surveillance camera, there are 3 types of sensor that we use, which is first IR sensor, PIR sensor, and temperature sensor. So Arduino as a microcontroller that can give a signal to the LCD and Wi-Fi modem. For the Wi-Fi modem, we give it receive the signal and give feedback to Arduino Uno. And for camera and DC gear motor, we use relay to control the camera and DC gear motor.
The conclusion, the development of remote controlled car using ESP32 or 8266 and Blink opens up an exciting possibility in the realm of DIY technique, right? So because of in this project, we learn how to connect Arduino, ESP32 with Blink application that could control for in a certain range, and also with the helps of Wi-Fi. It's really help in us to understand the operation of ESP32, and also um, helps in for the coding for we to integrate in such as subject as PSM1 and also TDP, because it's really we learn coding and everything that almost related to all of that.